One-step equations can be pretty easy, and you just need to remember this. You look at where the variable is in the equation. So like here's a variable, this p, this unknown number, and we want to get it all by itself. To do that, we're going to do the exact opposite. Sometimes this is called an inverse operation, okay? Inverse operation. I know my handwriting's a little sloppy there, sorry. But that just means we're going to do the opposite. So if it's p minus 1, we could literally just say plus 1 to both sides. Whatever you do to this left side of the equation, you're going to do to the right side of the equation. Why am I adding 1? Well, because there's a minus 1 sitting right beside that variable, and I don't want that minus 1 there. So if I do the opposite of what it says, instead of minusing 1, I say plus 1. Negative 1 plus 1 makes it go to 0, and the p is now free. And so I can do this equal sign there, and now negative 12 plus 1 equals negative 11. And you tell me, does negative 11 minus 1 equal negative 12? Well, yes, it does. Because when we keep the first sign, change the subtraction to a plus, and change the sign of the second number, it's negative 11 plus negative 1 equals negative 12. So yes, it really is negative 11 for our answer. And let's just go through and look at this again. You'll start to feel a bit more easy with this process here in a bit. B plus 9 equals 12.5. Well, here's my variable. The 9 is adding to that variable, so we're going to do the opposite of adding. We'll subtract, and since we added 9, we'll subtract 9. Well, 9 minus 9 is 0. That freed up my variable. But since I subtracted 9 on the left side of the equation, I better subtract 9 on the right side to keep the balance of everything. And b equals 3.5. And ask yourself, does 3.5 plus 9 actually equal 12.5? Yes, it does. So we know that we got the correct answer. And so that's how we handle the plus or minus problems for the most part. That'll get you through a lot of them. But then we got to look at this situation. What about when we have negative 2r equals 30? That means the negative 2 is timesing the r. Well, the r is on the left side. I need to get the r by itself. This negative 2 is multiplying it. The exact opposite is divide. So instead of timesing by negative 2, we'll divide by negative 2. And then do the same to the other side. Negative 2 divided by negative 2 is positive 1. It frees up the r. And 30 divided by negative 2 is negative 15. And yes, that works. Negative 2 times negative 15 is positive 30. This is one that causes a little bit of anxiety. And we need to look at it as not as a fraction, but what's happening to this variable and that number. We want to get this 5 away from the x. It's x divided by 5. So if we just did the opposite and multiplied by 5, it frees it up. And then we can do it to the same to the other side. So x is going to be, let's see, 135. If I made a mistake, just get a calculator out and trust the calculator. I'm doing this in my head kind of quick. Now this is a situation that we need to take a brief little pause to understand what's happening here. And that's the reason I put the star here. Negative 10 plus k equals 4. When we were doing the other problems, the variable came first. See, p minus 1, b plus 9. This time there's a number before the variable. Okay, so let's go back up here and take a look at this to see if this will get us ready. Do you see how we're looking in front of the 1? It was a minus sign, so we plused 1. And this was a plus 9, so we looked in front of the number. So it's minus 9. That's going to give us a hint with this right here. If I said, oh, it's adding negative 10, so let's just subtract negative 10. If people do this, you're going to have a problem where this equals negative 20, not 0. So we can't do that. We can't look behind the number. Look in front of the number. I know that's a negative sign, but what's opposite of a negative 10? How about a plus 10? And so negative 10 plus 10, that makes it a 0. And that lets the k drop down. And then since we added 10 to the left side, let's add 10 to the right side. And 4 plus 10 equals 14. Negative 10 plus positive 14 does indeed equal positive 4. So we know that we have the correct answer. I think I've got 2 other equations right here. This is one where suddenly it's not so easy anymore, and we need to take a look at how to do this. X is adding 1 5/8, and it equals 7/8. So since it's adding 1 5/8, we need to subtract 1 5/8. Well, 1 5/8 minus 1 5/8 is nothing, and so the x is free. And now we need to actually add the 1 and 5/8 to the other side. And I'm going to write this sideways here. I could put it right here on the bottom. That doesn't really matter anything. It doesn't change anything. And now we've got some options here. We can just add the fraction together, and then that would be an improper fraction, and convert that over. Or I can just convert this whole thing to an improper fraction right now. 8 times 1 is 8, and 8 plus 5 is 13. So this whole mixed number, 1 and 5/8, becomes 13/8, and that should be second nature. And so basically I'm going to add 13/8 to the 7/8. Okay. 7 plus 13 is 28. I can divide both of those by 2, so that becomes 10/4. I can divide both of them by 2 again to simplify it, and that becomes 5/2. And so basically I'm left with a situation that I can't go any further, but it's an improper fraction. So we do need to make it into a mixed number to finish simplifying it. 2 goes into 5 2 times. That would leave us 1 left over, so we use that for our new numerator. And 2 goes on for our bottom. So x equals 2.5. The next one's really not as complicated, but it just looks a little worse. We have 2/3 times k equals 7. And notice I said it's not 2/3 k, I said 2/3 times k. So this fraction right here is a number, and it's multiplying k. Well, we know that we should basically divide 2/3 by itself because it's the exact opposite of multiplying. So that frees up the k. But now I've got to divide this by 2/3. And it's basically this idea here. 7 is going to be divided by 2/3. Well, how do I make 7 into a fraction? Put a 1 under it. We can always do that with the whole numbers. Put a 1 under it. We can then change this division sign into multiplication. I prefer a dot, but I want to put the x multiplication symbol there. And then we flip the second fraction upside down. And now we can multiply straight across. 7 times 3 is 21, and 1 times 2 is 2. How many times does 2 go into 21? 10 times, with 1 left over, so k equals 10.5.